Okay, this is AS Mechanics 9709/42 October November 2020. Questions 3, 4, and 5. We have a block of mass M is held in equilibrium below a you have to know equilibrium below a horizontal ceiling by two strings as shown in the diagram. One of them is 45 degrees and the tension in it is T. The other one is 60 and the tension is 20. Find T and find M. We're going to start Oshi by drawing the free body diagram and resolving our forces into their components. So y and x. We're going to start first by showing the weight, which goes down. We're then going to show our two forces. We're going to call this one over here. I'm going to call it T1, and I'm going to call this one as T2, just for solving purposes. So T1. And over here, I'm going to have T2. We're going to put in brackets that T2 is 20 newtons. Okay, let's put our vector symbols. Let's choose the angle. Since the angle here is 45, if you draw your vertical over here, you can see that the angle here also is 45 degrees. So this one will be 45 degrees. Here, since the angle is 60, that means the angle over here will be 30 degrees. The reason for this, by the way, guys, is because here it makes a right angle and over here it makes a right angle. 60, so here will be 30 degrees. Okay, we know that T1 and T2, they must be resolved into their components. So we're going to draw this as T1x. We're going to draw this one up here as T1y. And over here, T2 must be resolved into T2x. And over here, T2y. Okay. So we now have all our forces. We can start by saying that sigma fx is equal to 0. Because it's in equilibrium, right? So I'm going to put a note up here. Sigma fx is equal to 0. Sigma fy is equal to 0. Okay. Sigma fx equals to 0. That means all the horizontal forces on the right are equal to all the horizontal forces on the left. So T2x is equal to T1x. T2x is equal to T2 sine 30, right? Because why am I using sine for the x component? Because the angle is with the vertical. T1x is going to be T1 sine 45. Remember, we're asked to find t, and in this case, I should have written on the side, let t equal T1. Okay, I should have written this on the side. Okay, just so the person correcting your paper knows what you mean by T1. Okay, so T2x equals T1x, T2 sine 30 is equal to T1 sine 45, because the x components, right? We know that T2 is equal to 20 newtons. It's 20 newtons, right? So I can replace it by saying 20 sine 30 is equal to T1 sine 45. Remember, one of the answers we're trying to find is find T1. Okay, so how would you find T1? We can just, we only have one unknown here. We can just divide by sine 45 on both sides. So you can get 20 sine 30 over sine 45. And you're going to get, let's do it on our calculator, 20 sine 30 divided by sine 45. And you get 14.1. Remember to three significant figures always. So it's going to be equal to 14.1. Why am I not putting the unit? Because it already has newtons. Okay. How about sigma Fy? We know it's also going to be equal to 0, right? What are my vertical forces? Let me separate these. My vertical forces are T1y, T2y, and W. We know what's up is equal to what's down. When you say it's equal to 0, that means it's balanced out. So what's up is equal to what's down. So we're going to say T1y plus T2y is equal to the weight, right? All right. T1y would be T1 cosine 45, right? And T2y would be T2 cosine 30. And weight would be mg. Let's continue. T1 cosine 45. We know T1 is 14.1, so we're going to replace this with 14.1 cosine 45 plus T2 cosine 30. We know T2 is 20, so 20 cosine 30 is equal to the mass, which is m that we're trying to find, times g. G is, we know it's 10, right? If it's not given, it's 10. Can you solve this, guys? Of course you can. You know, if you just divide by 10 on both sides, that m is just going to be equal to 14.1 cosine 45 plus 20 cosine 30 divided by 10. And let's do this on our calculator. 14.1 cosine 45 plus 20 cosine 30 over 10, which is 2.73 to three significant figures. So you're going to get m is equal to 2.73 kg. Okay, and they're asking for m kg, so we're just going to call it 2.73. Okay, let's check our marking scheme. We have over here question 3. The m is 2.73 and t is 14.1. So you would get 1 mark for this over here. To sign this over here, you get 1 more. Let's draw it in red. 1 mark for this. 1 mark for the answer over here. 1 mark for this over here. Wait, 20 sine 60, 20 cosine 30 plus t. Yeah, so you would get 1 mark, I think, for this one over here. 1 mark for this one. Wait, visual force vertically to 10, 20, 20. Yeah, so you'd get 1 mark. You get 2 marks over here, and then I'm presuming 1 mark for the answer. Yes, so you'd get 1 mark for the answer. So you'd get 2 marks for this. So these would be how your 5 marks are distributed. Okay. Then question 4. The diagram shows a VT graph which models the motion of a car, and the graph consists of 4 straight line segments. The car accelerates at a constant rate of 2 meters per second from rest to a speed of 20 meters per second over a period of t seconds. So we went from rest to 20 over a period of t seconds. It then decelerates at a constant rate for 5 seconds before traveling at a constant speed of v meters per second for 27.5 seconds. The car then decelerates to rest at a constant rate over a period of 5 seconds. Find t. One thing to pay attention to in the question is that they said that the car accelerates at a constant rate of 2 meters per second from rest to a speed. Oh, not like that. Yeah. So over here, it accelerates at a rate of 2 meters per second from rest to a speed of 20 meters per second over a period of t seconds. This, without even looking at the graph, well, they put the graph to help you. Without even looking from the graph, you can easily find the time. You guys know that acceleration is equal to delta v over t. And therefore, acceleration would be equal to final velocity minus initial velocity over the time. We know that it accelerates at a rate of 2. So we're going to write over here that 2 is equal to from rest. So my initial velocity is 0, right? To a speed of 20. So my final velocity is 20. My initial velocity is 0 over a period of t seconds. So this is my equation. So 20 over t is equal to 2. So easily you guys can find that t is equal to 20 divided by 2, which is equal to 10. There you go. 1 easy mark. Very, very easy. Okay. Also, you can see here it went from 0 to 20 over a period of 2 seconds. They told us that the acceleration is 2. So basically the slope here is equal to 2, by the way, because the slope of a VT graph is what? Acceleration, right? Okay. Part B, given that the distance traveled up to the point at which the car begins to move with constant speed is 1/3 of the total distance traveled, find V. So we're going to go back to our graph to help visualize what's going on here. Okay. We're talking about distances and we're talking about a VT graph. You guys should know that in a VT graph, or I'm going to say it and I'm crazy in a different way, that distance is equal to the area under the VT graph, right? So we're going to go up here. I just want to make sure, because in our school's marking scheme, if you don't mention this, you don't get a mark. But obviously in the AS marking scheme over here, they don't say it. Maybe implied if seen within. Yeah, so you don't really have to do it here. They just care about how you solve. But you're supposed to mention this, and you're supposed to mention the formula used for each shape, which is pretty annoying. However, I'm gonna show you all of this. So we said that t is equal to 10. So I'm gonna go back to my graph just so you can help visualize it. We have 10, okay, and we're gonna continue look at the times because you're gonna need the times to find the areas. So it goes up to 10, and then we said it then decelerates for 5 seconds before traveling at constant speed of 5. So decelerates to v for how many seconds? 5. So if it was 10 here, over here it would be 5 more seconds, 15. It then moves at a constant speed v for 27.5 seconds. So 15 plus 27.5, let me see, 15 plus 27.5, it should be 42.5. So over here, it would reach for 27.5 seconds. That means it would reach 42.5. And then over here, it said it decelerates to rest for 5 more seconds. So 42.5 plus 5 more seconds, 47.5. So basically now you have everything. You have all the times. We're trying to find our unknown v. So basically we should just find the distances. They told us that the distance traveled up to the point at which the car begins to move with constant speed is 1/3 of the total distance traveled. Okay, so up to which it moves in a constant speed is from 0 to 15, right? So basically they're trying to say that x 0, 15 is equal to 1/3 of the distance, total distance. So 1/3 of the total distance. Let's just say total. Yeah, x total. To make this a bit easier, because you guys know I always hate working with fractions, I multiply by 3 on both sides to get rid of this fraction. So I'm just going to say that 3 of x between 0 and 15 is equal to x total. Okay, so we're now going to find x 0, 15. We know that it's equal to, I'm going to split it. How much space do I have here? Oh, I don't have much. Okay, I'm going to try and make as much use as I can. X from 0 to 15, we're going to split it up into 0, 10, because this is a triangle over here, plus 10, 15, which is a trapezoid. Okay, so just mention it. It's going to be equal to 0, 10, plus x 10, 15. Okay, we're going to say here, x from 0 to 10 is equal to what? Since it's a triangle, we're going to say base times height over 2. Again, if you're watching this for the AS level, you don't need to mention formulas. But if you want to make your work cleaner, you might as well. So base times height over 2. The base is 10. The height is 20, right? So we're going to say 10 times 20 over 2. You know, I'm not going to write it like that. I'm going to make it actually write the fraction. 10 times 20 over 2, which is equal to 100. Then we're going to write on the side here. Okay, I'll put like a line. X from 10 to 15, it's a trapezoid, right? So we're going to use the fact that base times height over 2. Sorry. Base 1. Trapezoid is base 1 plus base 2 over 2 times the height. So what's it going to be equal to? What's base 1? Let's see. People mistake this for the base. No, this is the shape of my trapezoid over here. Like this. The bases are the parallel sides. So these two. My first base is 20. My second base is V, right? So we're going to say 20. This is where the V starts to play in. We're trying to find V. So 20 plus V over 2 times the height. The height between them is just the distance between the bases, which is from 10 to 15. Please don't say 15. It's 5. From 10 to 15, it's 5. Okay? So, therefore, we're going to get that x from 0 to 15 is just going to be 100 plus. I want to simplify this, okay? I'd hate keeping it like this, okay? I'm going to simplify this to be 10 plus v over 2 times 5, okay? So 100 plus 5 into 10 plus v over 2. What did I simplify? I just divided the 20 by 2, because you guys know 20 plus v over 2 can be split into 20 over 2 and v over 2. Okay, so 20 over 2 is 10, and v over 2 is just v over 2. Okay. I'm going to simplify this even more by distributing the 5 inside. So x 0, 15 is going to be equal to 100 plus 50 plus 5 v over 2. So you're gonna get it's 150 plus 5v over 2. This is x015. Okay, you're gonna need this. We're gonna write one beside. Okay, not one. I'm just gonna put it in like a box. Okay. Type. We want to know. We know that 3 times x015 is equal to x total. We need to find x total. X total is 015 plus what? Let's continue going. x015 plus the rest of this, right? And the rest of this is actually, by the way, is actually a trapezoid. Right? This is a trapezoid over here. This is the base 1, and this is base 2. So I can just find the area of this trapezoid. So it would be x015 plus x from 15 to 47.5. Okay? We know how much x015 is. Let's find x15, 47.5. X from 15 to 47.5. It's a trapezoid, right? So it's going to be equal to base 1 plus base 2 over 2 times the height. Our first base is from 15 to 47.5, which we said is, I just subtract them, 47.5 minus 15, which is, let's see, 22.5, I think. Oh, no, yeah, 32.5. So our first base is 32.5. Our second base is from 42.5 till 15, which is 27.5. So 32.5 plus 27.5 over 2 times the height. The height is just the distance between them, and that is how much? V, right? So times V. Let's simplify this. You're going to get 60 over 2 times V. So it's going to be 30 V. So X total is going to be equal to what? X015, which is 150 plus 50V over 2. Sorry, 150 plus 5V over 2. That's X015 plus 15, 47.5, which is 30V. So, which is going to be equal to 150 plus 32.5V. Because 30 plus 5 over 2 is equal to 32.5. This is X total. So, we now have two equations. What do we know? We know that we know that 3 times x015 is equal to x total. So 3 times 150 plus 5 over 2v. I'm going to use 2.5 instead of 5 over 2. 2.5v is equal to x total, which is 150 plus 32.5v. Distribute our 3, we're going to get 450 plus 7.5v is equal to 150 plus 32.5v. We're going to take the v's to each side. We can take the constants to each side. We get 300 is equal to 32.5 minus 7.5 is 25. So 25v. So again, v is equal to 300 over 25, which is, let's see, 12. So therefore, v is equal to 12. Yeah. Let's see what you would get marks on. The distance traveled before constant speed. So from x015, this. So you'd get 1 mark for this. Okay? So 1 mark for this one over here. You have to show your work, obviously, guys. 1 mark for distance traveled after constant speed, which is 30v. So 1 mark for this. Okay? I'm gonna put this, I should have put this in a box earlier. Anyway, 1 mark for, whoa, yeah, whoa, okay, 1 over 2 times, okay, yeah, so basically they just did what I did. They simplified. So the last 2 marks you would get would be from, so I kind of used the simplification already in the early steps. So I simplified it for you to get this and this. These are my 2 boxes. Okay. So you'd get the rest of the 2 marks from here and from the correct answer. Okay. That would be your full 4 marks. Question 5. A particle is projected vertically upwards with speed 40 meters per second alongside a building of height h. Given that the particle is above the level of the top of the building for 4 seconds, find h. I'm going to draw for you a schematic diagram just so you can kind of understand what's happening. We know the building has height h. Okay? A particle is projected vertically upwards, up like this, with v node equal to 40 meter per second. It's above the level of the top of the building for 4 seconds. So it goes and it's above here for 4 seconds. So this over here was 4 seconds. Okay? They want us to find the height. With this information, many students would be confused as to what they can do. I'm going to help you out over here. If it was 4 seconds for this whole trip, that means to reach the top over here would be 2 seconds, and to go back down would be 2 seconds. Okay, take this as a note always. So on the side, we could say the time from h to max height is equal to 4 over 2, which is 2 seconds. So we know that it took 2 seconds to go from h to the maximum height. Okay, let's look at this. We know that this is projectile motion because it's projected vertically upwards. Take the keyword vertically upwards. That means it was projected at an angle of theta equals 90 degrees. Can you find, we know many people, I mean, I don't know if people use this formula outside of our school, but we know that the time to reach max height has a formula which is v node sine theta over g. So in this case, v node is 40, theta is 90, and g is always 10 if not given. And when you do this on your calculator, you get 4 seconds. So it took 4 seconds to reach maximum height. And we know that it took 2 seconds to go from h to maximum height. Right? So from h to the maximum height. Therefore, how many seconds were left? That means it also took 2 seconds to go from y0 to h. So we're going to put, therefore, it took 2 seconds to go from y0 to h. And we know in projectile motion, we have our time, 2 seconds to reach h. We have v node, and we have theta. Don't you think we can find the vertical distance it traveled? Yes, we can. Y is equal to minus half gt squared plus v node sine theta t. Right? Let's solve this. So y is going to be equal to minus half g, which is 10, t, which is 2, we have to square it, plus v node sine theta, so 40 sine 90 times the time, which is 2. So you're going to get y is equal to minus 5 times 4 minus 20 plus 40 sine 90 times 2 is, let me put sine 90 in brackets, is 80. So therefore, y is equal to 60. Therefore, h is equal to 60. meters. No, they said h meters, so h is just equal to 60. So let's see. It's a 4-mark question. What would we get marks on? 40 minus gt equals 0. Basically, t is equal to 40 divided by g, like we did over here. So this would be your first mark, the time to reach maximum height. Then the time from the top of the building would be 4 minus half of 4, which is 2. So it took 2 seconds to go from h to h max. Then they did y equals minus half gt squared, like we did over here. This would be 1 mark, and then 1 mark for the correct answer. Okay? There you go. Part B. 1 second after the first particle was projected, a second particle is projected vertically upwards from the top of the building with a speed 20 meters per second. Denoting the time after projection by t seconds, denoting the time after projection of the first particle by t seconds, find the value of t for which the two particles are at the same height above the ground. So I'm going to make my life a bit easier. I'm going to call the first particle particle 1 and the second particle I don't know, 2. Okay? So they want the same height above the ground. So basically they're saying y1 is equal to y2. Okay. First, I'm going to tell you that that y1 is equal to y2 plus 60. Why? Because they said that the second particle was projected from the top of the building. And we said that the building was 60. So if you were to draw it, you'd have the particle already here and this particle here. This is above it by the height of the building, which we found was 60 meters. Okay? So y1 is equal to y2 plus 60. Okay? Let's find an expression for both y1 and y2. y1 is equal to minus half gt squared plus v node sine theta t. So we're going to get that y1 is equal to minus 5 t squared plus 40 t. I'm actually going to solve it for you. Minus half times g, which is 10, t, which we're trying to find, plus v naught sine theta. It was projected, remember, particle 1 was projected at 40 meters per second, vertically upwards, so 40 sine 90. T. Therefore, it's equal to minus 5t squared plus 40. This is y1. How about y2? Now, y2 is going to be interesting because it's going to be the same thing, but instead of t, we're going to use t minus 1 because they said t is the time of the first particle. But relate the two particles. The second particle was projected 1 second after the first particle. So if the first particle is moving, so the time is continuing, right? But remember that the second particle only joined in over here after 1 second. So the time would be the same time as the first particle, but just 1 second less, right? So we're going to use t minus 1 as our time for the second particle, okay? So over here for the second particle, we're going to say same formula, minus half gt squared. We're going to use minus half times g, which is 10, times t, which we're going to use as t minus 1 squared, plus v naught sine theta. 20 is our v naught, and it was also projected vertically upwards. So theta also equals 90 degrees. So v naught sine theta, so it's going to be 20 sine 90 t minus 1. So what we're going to get? We're going to get minus 5 t minus 1 squared plus 20 sine 90, so 20 t minus 1. So this is y2. We know y1 is equal to y2 plus 60. Okay, so y1 is equal to minus 5. Okay, so I'm just going to rewrite this, y2 plus 60. So I'm going to rewrite that minus 5t squared plus 40t is equal to minus 5 t minus 1 squared plus 20 t minus 1 plus 60. Because remember, it's equal to y2 plus 60. Now you solve this as if it's a normal equation. You're going to get minus 5t squared plus 40t into minus 5. This is a minus b squared. So t squared minus 2t plus 1, right? Remember, a minus b squared is equal to a squared minus 2ab plus b squared plus 20 into t minus 1. Let's just distribute it with 20t minus 20 plus 60. So let's continue solving. Distribute, simplify, whatever. Minus 5 times t squared is minus 5t squared. Minus 5 minus 2 is going to be plus 10t. Minus 5 times 1 is minus 5 plus 20t minus 20 plus 60. I'm going to make my life easier by cancelling minus 5t squared on both sides. 10t plus 20t is equal to 30t. So I'm going to take it down as 30t. Cancel them both. Minus 5 plus 60. By the way, in the actual exam, don't cancel, okay? Because your examiner actually has to see what numbers you're using, okay? So let me not cancel. Let me just write it down, okay? So 10t, 20t, 30t. Okay, so you're done from these two. Let's underline them. Actually, underline them. We said these ones you can don't cancel them. Again, don't cancel them. Okay? Just put underline. Okay. Minus 5 minus 20 is minus 25. Minus 25 plus 60 is plus 35. So underline them to know you're done from them. Equals, remember we cancelled minus 5t squared on both sides. 40t. So you're going to get, take t to the other side. You can get 10t is equal to 35. Therefore, t is equal to 35 over 10 is equal to 3.5. Let's check the marking scheme. The height of the first particle, the height of the second particle. So, y1 and y2. You'd get 1 mark each. 1 mark for y1, 1 mark for y2. 1 mark for 60 plus whatever. So 1 mark for this over here. And then 1 mark for the answer. Yes. That's it for question 5. So questions 3, 4, and 5 are done. Thank you so much for watching. Good luck in your exam.